In a rice paddy in Heilongjiang province in the summer of 2021, a 60-year-old farmer watched a machine hover 30 feet above his crop and laughed out loud. Not a polite laugh, not a nervous laugh, but the deep, unself-conscious laugh of a man who has seen enough broken promises to know exactly what failure looks like before it happens. He had buried enough shattered equipment in the back of his barn to fill a small museum of bad ideas. What he didn't know, standing there at the edge of that flooded field with mud on his boots and doubt written all over his face, was that this machine was about to make him look very, very wrong. The problem nobody wanted to solve. Here is a number that should stop you cold. In 1960, roughly 60% of China's total workforce worked in agriculture. By 2023, that number had collapsed to roughly 24%. And the people still farming weren't young. The average age of a Chinese farmer today sits somewhere between 50 and 55, depending on the province, with some rural counties reporting that the majority of active farm workers are over 60. Think about that for a second. The people feeding 1.4 billion humans are, in many places, closer to retirement age than to 30. And it's not just who is farming, it's where. China doesn't have the luxury of the American Midwest, those vast flat plains where you can drop a GPS guided combine harvester and let it run from horizon to horizon. Chinese agriculture is fragmented, ancient, and deeply complicated. Terraced hillsides carved into mountainsides 2,000 years ago, flooded rice paddies that a wheeled vehicle simply cannot enter, plots so small and so irregularly shaped that a standard tractor would spend more time turning around than actually working. The average size of a Chinese farm holding is roughly zero point 0.6 hectares. For reference, the average American farm is over 180 hectares. These are not the same problem. They are not even the same category of problem. Western agricultural technology companies understood this. They took one long look at the terrain, the fragmentation, the flooding, the slopes, and they made a quiet, rational business decision. They would focus their precision agriculture investments on large, flat fields in places like the United States, Brazil, and Australia, where the economics made sense and the engineering was tractable. Asian smallholder farming, with its impossible patchwork of tiny, flooded plots on the sides of mountains, was someone else's problem. It turned out it was China's problem, and China, being China, decided to solve it. The machine they laughed at, the company that started this story, wasn't an agricultural company. It was a drone company, and not originally a very serious looking one. DJI, founded in Shenzhen in 2006 by a 26-year-old engineering student named Frank Wang, built its early reputation on consumer camera drones. The kind of thing you bought to film your holiday or crash into a tree on the weekend. Serious agricultural engineers were not exactly trembling with anticipation. But in 2012, DJI began developing something different, a drone designed not to film crops but to spray them. The concept was simple enough in theory. Fill a tank with pesticide or fertilizer, mount it under a drone, fly it precisely over a field, and spray exactly what's needed, exactly where it's needed, without a human wading through the crop, carrying a tank on their back. In practice, the early prototypes were, let's be kind here, a work in progress. They were loud, unstable, prone to catastrophic failure at the worst possible moments, and deeply unconvincing to the farmers they were supposed to serve. The first demonstrations did not go smoothly. There were crashes, there were malfunctions. There were moments where a machine worth tens of thousands of yuan pancaked into a rice paddy in front of an audience of skeptical farmers who had been pulled away from actual work to watch this. Word spread in the way that word spreads in farming communities, which is to say quickly and without mercy. The drone people from Shenzhen came to spray the field and drowned their machine in it instead. Ha! But DJI kept going, because the engineering team understood something the laughing farmers didn't yet. The problem wasn't the concept. The problem was the hardware generation. And hardware generations, when a company is moving fast enough, don't last long. By 2015, the Agris MG1 launched. 8 rotors, 10-kilogram payload, designed from the ground up for agricultural use. It wasn't perfect, but it worked. And for the first time, something that was supposed to work actually did. The laughter started getting quieter. What this thing actually does. Let's talk about what these machines became, because the Agris T50, which is where the technology stands today, is not the thing you're picturing when you hear the word drone. This machine weighs 40 kilograms when fully loaded. It carries a 50-kilogram payload split between a 40-liter spray tank and a 30-kilogram spreading hopper for solid materials like seeds and granular fertilizer. It has 8 rotors arranged for maximum stability in wind. It can fly in rain. It operates in temperatures from -10 to 45 degrees Celsius. And it doesn't just spray, it thinks. The T50 is equipped with an active phased array radar and a binocular vision system that map the terrain beneath it in real time. As the drone flies over a field, it's continuously measuring the distance to the crop canopy and adjusting its spray height to maintain a consistent application rate regardless of whether the ground is flat, sloped, or undulating. It knows the difference between a rice plant and the end of the field. It knows when it's flying over a gap in the crop and cuts the spray automatically so it's not wasting material on bare soil. These aren't gimmicks. These are engineering solutions to problems that have cost farmers billions in wasted chemicals over decades. The spray system itself breaks the liquid into droplets small enough to penetrate the crop canopy, but large enough not to drift when there's any wind. The nozzle pressure, droplet size, and flow rate are all controlled by onboard AI and adjusted on the fly. And when the tank runs dry, the drone doesn't just stop and wait for a human to notice. It logs exactly where it stopped, flies back to a refill station, and when it returns, picks up spraying from the precise point where it left off, without being told, without a human directing the process. Mission planning is done on a tablet. You draw the boundary of your field on a satellite map, set your parameters, and press go. The drone plans its own flight path, calculates the optimal coverage pattern, estimates material usage, and executes the job. One operator, multiple drones, fields that would have taken a team of workers multiple grueling days to treat by hand, finished in hours. And DJI isn't alone in this space anymore. Companies like ZAG, based in Guangzhou, have built entire agricultural robot ecosystems around the drone. Autonomous ground rovers that refill the drones in the field without human intervention. AI soil sensors that feed data directly into the mission planning software. Satellite imagery integration that flags areas of the field showing signs of disease or nutrient deficiency before they're visible to the human eye. This is not one machine. This is a system. And the system is getting smarter with every single flight. The numbers that silenced the laughter here is where the script of what was supposed to happen diverges sharply from what actually happened. One agricultural drone operating at full capacity can treat roughly 400 to 600 MU of farmland per day. A MU is a traditional Chinese unit of area, roughly equal to 667 square meters. Do the conversion, and you're looking at somewhere between 27 and 40 hectares of treated farmland in a single day, from a single machine, operated by a single person. The manual equivalent, a worker with a backpack sprayer covering roughly 3 to 5 mu per day, means you would need somewhere between 80 and 200 workers to match what one drone and one operator can accomplish. Let that land for a second. One person, one machine. The output of up to 200 farm workers. And the cost comparison is not close. Manual spraying in China costs roughly 30 to 60 yuan per MU, depending on the region and the labor market. Drone spraying, once the equipment cost is amortized, comes in at 8 to 15 yuan per mu. You are cutting your input cost by more than half, while dramatically increasing the consistency and precision of application. Every farmer who runs these numbers arrives at the same conclusion. The math isn't complicated, it's just surprising. By 2023, China had registered over 160,000 agricultural drones in active service. These machines collectively treated over 1 billion MU of farmland annually. 1 billion. That is an area roughly equivalent to the entire agricultural land area of Germany and France combined, treated by machines that a decade ago didn't exist. Agricultural drone flight hours in China in 2023 exceeded 60 million. That's more flight time than many national air forces log in a year. The government noticed. Of course the government noticed. Beijing began subsidizing agricultural drone purchases in 2014, and those subsidies accelerated dramatically through the late 20-teens. In some provinces, farmers could claim back 30 to 50% of the purchase cost. The result was adoption at a speed that Western agricultural economists openly admitted they had not predicted. One researcher at Wageningen University in the Netherlands, which is arguably the world's foremost institution for agricultural science, described China's agricultural drone adoption curve as, and I'm paraphrasing here because we don't do direct quotes around here, essentially unprecedented in the history of farming technology. It didn't stop at drones. Now here's the part where most coverage of Chinese agricultural technology stops. The drone story is dramatic enough, the numbers are big enough, and the before and after photographs of a drone hovering over a rice paddy are compelling enough that most journalists close their notebooks and call it a day. But the drone is just the most visible corner of something much larger. While the drones were getting the headlines, Chinese companies and research institutions were quietly building out a complete technological stack for precision agriculture that reaches from orbit down to the individual root system of a single rice plant. Start from the top. China's Beidou satellite navigation system, completed in 2020, provides positioning data accurate to the centimeter level across the entire country and most of Asia. This isn't GPS. This is a Chinese-built, Chinese-operated global navigation system with agricultural applications baked in from the design stage. Autonomous tractors equipped with Beidou receivers can now plow, plant, and harvest with centimeter-level accuracy, running parallel passes so precise that the overlap between adjacent rows is measured in millimeters. These tractors operate day and night. They don't get tired. They don't need headlights because they're not driving by sight. They're driving by satellite. Then there's the soil layer. Companies like Exag and a Hangzhou-based firm called Alibaba Cloud's agricultural division have deployed networks of AI-powered soil sensors across pilot farming regions in Xinjiang, Heilongjiang, and Anhui provinces. These sensors measure moisture content, nitrogen levels, pH, organic carbon, and temperature at multiple depths, transmitting data continuously to cloud platforms that build dynamic maps of soil health across entire farming regions. Irrigation systems connected to these platforms adjust their output in real time, field by field, zone by zone, delivering precisely the water each section of crop actually needs and nothing more. Then comes planting. Robotic rice transplanting machines, which look roughly like a ride-on lawnmower if a ride-on lawnmower had 6 arms and the spatial awareness of a neurosurgeon, can plant rice seedlings at a rate of 2 to 3 mu per hour with a precision and consistency no human worker can replicate over the course of a full day's labor. The spacing is perfect. The depth is uniform. The survival rate of transplanted seedlings is measurably higher than manual planting because the machine doesn't get tired and start rushing at 4 in the afternoon. And wrapping all of it together is a layer of artificial intelligence that most people outside the Chinese agricultural technology industry have simply never heard of. Platforms like the Alibaba Cloud, ET Agricultural Brain, and the DJI Agriculture Management Platform aggregate data from drones, soil sensors, weather stations, satellite imagery, and historical yield records to generate field-by-field recommendations for every intervention a farmer makes across the entire growing season. What to plant, when to plant it, how much water, how much fertilizer, when to spray, when to harvest. The system learns from each season and gets more accurate every year. This is not a drone story. This is a civilizational scale bet on intelligent agriculture. The terrain problem nobody thought was solvable. Here is a fact about Chinese agriculture that tends to produce a moment of silence in rooms full of agricultural engineers. Roughly 30% of China's arable farmland sits on slopes greater than 6 degrees, and a significant portion of the country's rice cultivation happens in flooded paddies on terraced hillsides that have been carved by hand into mountainsides across 2,000 years of farming history. These fields are beautiful. They are also a logistical nightmare. Western precision agriculture companies, to their credit, never pretended they had a solution for this. John Deere's autonomous systems are extraordinary on flat, large-scale grain operations in the American Midwest. They were not designed for a half-hectare terraced paddy on the side of a mountain in Yunnan province. The terrain, the flooding, the fragmentation, and the sheer variety of microclimates across a single hillside make the application of standard precision agriculture technology somewhere between impractical and impossible. DJI and XAG didn't solve this problem by ignoring the terrain. They solved it by building machines that understand terrain the way a skilled pilot does, except faster and without the risk of vertigo. The terrain following capability of the Agras T50's radar system allows it to maintain a constant spray height above the crop's surface, even when flying across a hillside where the elevation changes by several meters within a single pass. The machine is not flying a programmed altitude, it is flying a programmed distance above whatever is directly below it constantly in real time. For autonomous ground equipment, the challenge was different and in some ways harder. Chinese agricultural robotics companies developed lightweight tracked vehicles, essentially small robots on tank treads that can navigate the narrow bunds between terraced paddy fields without slipping, without compacting the soil excessively, and without falling into the water. These aren't prototypes in a laboratory. They are operating in Guangxi, Hunan, and Sichuan provinces right now, doing work that a decade ago required either human labor or simply didn't get done. The fragmentation problem was addressed differently again. Digital field mapping systems allow farmers to register every individual plot they own or manage, regardless of how small or irregular the shape, into a centralized platform. The drone's flight planning software then generates custom coverage patterns for each shape. A drone servicing a fragmented operation of 40 separate tiny plots can load all 40 missions, execute them sequentially, and cover every square meter of every field in a single day. No plot is too small, no shape is too weird. The machine adapts to the landscape instead of demanding the landscape adapt to it. What this means for the world. China currently feeds approximately 18% of the global population on approximately 7% of the world's arable land. That ratio has always been the central tension of Chinese agriculture, and it is the reason the Chinese government has treated food security as a matter of national survival for decades. But what's happening now isn't just about feeding China, it's about exporting a solution. In Southeast Asia, where rice cultivation faces nearly identical challenges to China, the adoption of Chinese agricultural drones has been rapid and, in some cases, transformative. In Thailand, the Philippines, Vietnam, and Indonesia, tens of thousands of DJI and XAG drones are now operating commercially. Filipino rice farmers report labor cost reductions of 30 to 50% per growing season. Vietnamese cooperatives operating drone fleets have documented yield increases of 8 to 15%, driven largely by the improved precision and consistency of pesticide and fertilizer application. In sub-Saharan Africa, where agricultural labor productivity remains critically low and climate volatility is increasing, Chinese companies are actively piloting drone-based crop protection programs in countries including Nigeria, Kenya, and Ethiopia. These are not charity projects, they are market development exercises, and they are working. The economics of drone agriculture translate across contexts in a way that most agricultural technology doesn't, because the core value proposition, replacing expensive and increasingly scarce human labor with a precise, tireless machine, applies almost everywhere that food is grown. In Latin America, Brazil's vast agricultural sector, already one of the most technologically sophisticated on Earth, is beginning to integrate Chinese agricultural drone technology at scale, not as a replacement for existing precision agriculture systems, but as a complementary layer for crops and terrain types where ground equipment cannot reach. And this is where the geopolitical dimension of the story starts to get interesting. Because China isn't just selling drones, China is selling a system. And a system comes with data flows, software dependencies, ongoing service relationships, and a degree of technological lock-in that governments paying attention are beginning to scrutinize very carefully. The United States has already moved to restrict DJI drones from certain government and military applications due to data security concerns. Several European governments are reviewing their positions. The question of who controls the technology that feeds you is not an abstract one. It is becoming quietly and uncomfortably one of the defining questions of the next decade. The part that should make everyone pay attention. Let's talk about the thing underneath the thing, because there's a layer to China's agricultural drone story that almost never makes it into the mainstream coverage. And it is arguably the most consequential part of everything we've discussed. Every agricultural drone flight generates data, a lot of data. Multispectral imagery of crop health, precise spray records down to the individual meter, terrain maps, yield correlation data. When you scale that data collection across 60 million flight hours per year, operating across every major agricultural region in China, what you are building is not a collection of isolated farm records. What you are building is the most comprehensive, continuously updated, high-resolution map of agricultural conditions on Earth. China's government has been explicit about its intention to build a national agricultural data platform that aggregates information from drones, satellites, sensors, and farm management systems across the country. The stated purpose is to improve food security planning, optimize resource allocation, and support farmers with better decision-making tools. And those things are genuinely useful and genuinely happening. But the same data set that tells you how the wheat crop in Hebei province is performing this week also tells you with considerable precision what the national harvest is going to look like before a single combine has moved. That is information with implications that extend well beyond the farm gate. Agricultural commodity markets move on crop forecasts. Trade negotiations hinge on supply projections. Food import decisions by governments around the world are made on the basis of information that is, in most cases, less precise and less current than what China's National Agricultural Intelligence Network can now generate domestically. The country that knows its own harvest with the greatest accuracy and that knows it earliest has an advantage in global food markets that is structural, not incidental, and that compounds every single season as the data pool deepens and the AI models get smarter. This is not speculation. This is the logical extension of a data collection infrastructure that already exists and is already operating at scale. Whether or not it is being exploited to that degree today is a question that agricultural economists and intelligence analysts are beginning to ask with increasing urgency. And the fact that most people outside a small circle of specialists have never heard of it tells you something about how quietly this particular development has unfolded. The farmers who laughed. Last, let's go back to Heilongjiang, back to that 60-year-old farmer standing at the edge of his paddy in 2021, watching a machine hover over his field and laughing. His name, for the purposes of this story, is the story of about 3 million Chinese smallholder farmers who went through a version of the same arc between 2018 and 2023. Skepticism, reluctant curiosity, grudging trial, surprise, adoption. He didn't buy a drone himself at first. He hired a drone service operator, one of the tens of thousands of small agricultural service businesses that have emerged across rural China to operate drones on behalf of farmers who don't want to own or learn the equipment themselves. The arrangement is simple. You pay per MU. The operator handles the machine, the mission planning, the chemicals, and the filing. You go do something else. For a 60-year-old man whose knees hurt from decades of bending in flooded fields, the appeal of that arrangement is not difficult to understand. The first season, he was watching carefully, the way you watch something you don't fully trust. The second season, he was comparing yields with neighbors who had stayed with manual methods. The third season, he signed a full season service contract covering every spray application from germination to harvest. By the fourth season, he had quietly enrolled in a local training program and gotten his own agricultural drone operator's certification. He now contracts his services to 12 neighboring farms during the growing season. He is 63 years old. He operates a DJI Agris T40, and he has not spent a single day wading through a paddy with a tank on his back since 2022. The machine they laughed at became the machine they couldn't farm without. And that, more than any specification, any sales figure, any government subsidy number, is the story of what China built in a rice field, not a drone, a future that works, and it's only getting started.